Myself, Farzana Begum, lecturer in economics, GDCW, Golconda. Today we will discuss about the isocont analysis. What is isocont? Isoproduct curve or isocont curve. Isocont may be defined as a curve showing of the various combinations of two factors that can produce a given level of output. In Latin, iso means equal and cont means quantity. Equal quantity. Equal product curve or equal product curve in production are similar to the indifference curve in consumer behavior. They are also known as isocont. Isoproduct curve meaning equal quantities of output and equal product curve represent all those input combinations that are capable of producing the same level of output. As this combination produce the equal output, the producer will be indifference between them. In other words, as the various combinations on the isocont give the same level of output, the producer has no strong preference for any one particular combination of factor. Isocont schedule. This concept of isocont can be easily explained with the help of the table given below. Assume that two factors L and K produce a particular commodity of combinations A, B, C, D. Of these two factors give the same level of output. Here, look here, 100, 100, 100. Factor of combination bundles A, B, C, D. Factors, two factors are there, L and K. In combination A, factor of L, 5 unit of L plus 9 unit of K. In combination B, 10 unit of L and 6 unit of K. In combination C, 15 unit of L plus 4 unit of K. In combination D, 20 unit labor plus 3 unit of capital. The above table is based on the assumptions that only two factors of production, that is labor and capital, producing 100 meter of clothes. Combination A is equal to 5L plus 9K is equal to 100 meters of cloth. Combination B is equal 10L plus 6K. In combination C, 15L plus 4K. In combination D, 20L plus 3K is equal to 100 meters of cloth. The contributions A, B, C, D show the possibility of producing 100 meters of isocont schedule is a schedule of different combination of factors of production yielding the same quantity of output. So here different combination A, B, C, D, these are the different factors, also different, but quantity is same quantity of output, 100 meters cloth only. Isocont is a curve showing combination of labor and capital. So here you can see IQ is a isocont curve. Thus an isocont is a curve showing all combination of labor and capital A, B, C, D that can be used to produce a given quantity of output. Now O-axis showing labors and Y-axis showing the capital. Isocont map. The isocont map comprises of family of equal product curves producing various quantities of output by producing 100, 200, 300 units of output of a commodity. A higher isocont uses more quantity of both the factors L and K and hence produces a higher level of output when compared to a lower isocont IQ1, IQ2, IQ3. The downward slope of the isocont is due to the technical substitution between factors L and K. The marginal rate of technical substitution in isocont analysis of production is similar to the marginal rate of substitution in indifference curve analysis in consumption. Marginal rate of technical substitution of factor L for K may be defined as the amount of factor K which has to be foregone to increase factor L by 1 unit. To shift from combination A to B, that is to increase factor L by 1 unit, the firm has to forego four unit of factor K. To shift from combination B to C, 3 units of K, and from C to D, 1 unit of K are to be foregone. Start. Properties of isocont. Isocont are convex to the origin. A convex curve has negative slope. If the output is to remain constant when the quantity of one factor is increased, the quantity of the other factor has to be reduced. The convexity of the equal product curve is due to the diminishing marginal rate of technical substitution on isocont. Isocont do not intersect each other. A higher isocont give a higher level of output than a lower isocont. If one isocont corresponds to 20 units and another 30 units of output intersects each other, the same combination can produce 20 unit on the lower isocont and 30 unit of higher isocont. Sounds absurd. Therefore, isocont do not intersect each other. The two exceptions to the downward sloping isoconts are the cases of factors that are either perfect substitute or complementaries to each other. The isocont for perfect substitutes is a straight line sloping downward. This is because the MRTS between the two factors remains the same throughout as in the case of perfect complementary factors, no substitution is possible between the factors and the isocont is right angle as shown in the figure. Isocont are never parallel to the x-axis or y-axis. Never horizontal to the x-axis or y-axis. No two curves intersect each other. Each isocont is a part Isocont line represent various technical possibilities of producing a given level of output. The choice of a particular combination that maximizes the profit of a firm depends upon technical possibilities of production and the prices of the factors used in the production of the commodity. The prices of the factors L and K are represented by the isocost line. So here, the choice of a particular combination that maximizes the profit of a firm depends upon the technical possibilities of production and the prices of the factors used in the production of the commodity. The prices of the factors L and K are represented by the isocost line. The concepts of isocost line in production is similar to the concepts of budget line in indifference curve analysis. The isocost line shows the various combination of factors L and K the firm can employ with the given output, assuming that the prices of the factors are given and remain constant. The isocost line thus show the relationship between the prices of two factors L and K, the total outlay. An isocont explains the various technically possible combinations of factors x and y that can produce the same level of output. An isocost line represents various combinations of input which a firm can purchase with the given today given outlay and the prices of the two factors, the firm in the equilibrium at the optimum factor combination. The optimum factor combination is attained if we bring the isoquant and isocost line together. Here you can see, suppose the producer has decided the level of output of the firm has to produce. To produce that level of output, he has to choose that combination of factors which minimize the cost of production. It is only with the production at least cost combination. The firm maximizes profit at an attain equilibrium. This figure explains the optimum combination of production of the firm. The firm has decided to produce, suppose, 200 units of output. R, S, Q, L, K are the various combinations on isoquant. Isoquant IQ that can produce 200 units of output A, B, C, D or E, F and G, H are four different isocost lines. Outlay with the given prices of the factors X and Y, the 200 unit of output can be produced by combination here R and K on the higher cost line GH combinations, SL and R on isocost line, EF which is lower than GH but higher than CD. It is only at combination Q. The isocost line CD is the tangent to isoquant IQ. Hence, the firm is an equilibrium at combination Q and is using OM unit of factors L and K. So here point E, the firm is in equilibrium. The equilibrium of the firm can also be explained considering the MRTS and the ratio of prices of the two factors L and K. MRTS of the factors is given by slope of the isoquant and the ratio of prices is given by the slope of the isocost line. At combinations, suppose R and S, MRTS is greater than the ratio of prices of factors L and K. At combination K and L, MRTS is less than the ratio of power factors L and K. At combination R and S, MRTS XY is greater than PX by PY. At combination K and L, MRTS XY less than PX by PY. At combination Q or isocost line is tangent to the isoquant. The slope of isoquant and isocost line are equal at the point E. Hence, the optimum combination of produce in this graph 150 units of commodity. Returns to scale. Law of returns to scale explain the changes in output in the case where some factors are fixed and other are variable. They related to the short-run changes in output. Returns to scale explain the long-run changes in the production relation. When all factors are varied in returns to scale, the factor can be increased in two ways: increasing all factors in the same proportion, increasing all factors by altering the proportion. When all inputs are increased, returns can be increasing, constant or diminishing. Returns to scale are said to be increasing when a proportionate increase in all unit inputs result in a more than proportionate increase in output. Returns to scale are said to be constant when a proportionate increase in all the inputs result in same proportionate increase in output. Returns to scale are said to be diminishing when a proportionate increase in all the inputs result in a less than proportionate increase in output. So here three stages of returns to scale. First one increasing, then constant, and then diminishing. Assuming that the prices of factors of production to be constant, increasing returns to scale are associated with diminishing cost. Constant returns to scale are associated with constant cost, and diminishing returns with increasing cost. Returns to scale can also be explained with isoquant. Increasing returns to scale occur in the early stages of expansion as the firm enjoys internal and external economies of scale, and diminishing returns after a certain level of production due to internal and external diseconomics of scale. Internal economics are the economies that occur to the firm from which the organization due to large scale of production, but they do not benefit the entire industry. They are technological economies, managerial economies, marketing economies, financial economies, and risk-bearing economics. Technological economics occurs to the firm due to higher investment. Higher investment results in more capital intensive, sophisticated technology that increase output rapidly and lower the cost of production. Higher the capital intensity, more is the output. Managerial economics, large scale production necessitates specialization and division of labor. The division of production process into various process and sub-process that are headed by expert in the field result in intensive use of capital, avoidance of wastages and delay in production. It also saves labor. This division of labor drastically reduce the cost of production. This type of specialization is termed as vertical specialization. Marketing economics. As the size of the firm expand, its sales and purchase will increase. At a considerable level, firms can realize economies through wholesale purchase of raw materials at cheaper prices as the firm produces output at a higher level. It can maximize profit by selling its product in multiple markets. Financial economics and risk bearing economics. External economics are those economics that occur to the firm as an industry expands. External economics are a result of expansion of output of the whole industry and are not dependent on the output of an individual firm. These advantages are called external economics as they benefit the firm from outside. Thus, the external economics are result of expansion of industry and benefit all firms in the industry. So, returns to scale have three stages. In first one is increasing returns to scale, and second one constant returns to scale, and third stage diminishing returns to scale. So here we can see increasing returns to scale. This isocon shows a firm when it is enjoying increasing returns to scale. IQ1, IQ1, IQ2, IQ3, IQ4. You can say 100 kg, 200 kg, 300 kg, 400 kg. So here this line shows the expansion path of the firm. Increase in quantity is greater than increase in capital and labor. IQ isocon curve is shown here, combination of L and K. In this figure, the scale line and shows various amount of output that can be produced at the lowest possible cost of production. When both the factors L and K are variable and their relative prices remain constant, the firm will always fix its scale of output at some points along the scale line. Here 4 isocon producing 100, 200, 300 and 400. As the output is increasing more than proportionately, the distance between the isocon is decreasing. Here AB is greater than BC is greater than CD. Next stage, constant returns to scale. Constant returns to scale are a transition phase between increasing and diminishing returns to scale. In constant returns to scale, a proportionate increase in input increases output in the same proportion. Here you can see OP, the distance between the equilibrium points on isocon producing 100, 200, 300, 400 unit of output is equal. AB is equal to BC is equal to CD. So in other words, an increase in input in some proportion increase output in the same proportion. Constant returns are associated with constant costs. Decreasing returns to scale. Decreasing returns to scale is said to occur when a proportionate increase in input causes a less than proportionate increase in output. When the firm continues to increase the scale of production after a certain level of production, diminishing returns to scale occur. Some economists argue that diminishing returns occur because the entrepreneur is a fixed factor of production, and when all other factors can be increased, the entrepreneur as a factor remains constant. Others who counter this line of reasoning argue that after a certain scale of production, diminishing returns occur. Decreasing returns to scale is shown with ISO product curve. The distance between the isocont on the scale line is increasing. AB is less than BC is less than CD, indicating that to increasing the output in the same scale, more quantity of factors are needed. Decreasing returns to scale are associated with increasing cost. Next type of production function, linear homogeneous production function. Linear homogeneous production function is the most popular function amongst economists. It is also known as the production function of first order, indicating that if all the factors are increased in same proportion, output also increase in the same proportion. Linear homogeneous production function represent the case of constant returns to scale. Assuming that there are two factors K and L, a linear homogeneous production function can be mathematically expressed as NQ is equal to function of NK and L, where Q stands for total production, K and L are two factors of production, say capital and labor. N is any real number. The above relation shows that if factor K and L are increased n times, the total production also increased by n times. Thus, linear homogeneous production function of first degree denotes constant returns to scale. The linear homogeneous production function implies that with line proportionate change in all the factors of production, the output also creates in the same proportion, such as if the input factors are doubled, the output also get double. This is also known as constant returns to scale. The production function can be shown in symbolically. NP is equal to function of NK and L, where N number of times, NP number of times the output is increased, NK number of times the capital is increased, NL the number of times the labor is increased. So here we can see, in the case of linear homogeneous production function, the expanse always as a straight line through line the origin as shown in the figure. This the proportion between the factors used will always be the same. Cobb-Douglas production function. Cobb-Douglas production function, named after the two American economics C.W. Cobb and Paul H. Douglas, is the most widely used production function in empirical studies. Originally, the Cobb-Douglas production function was applied to the production process for the American manufacturing industry to compute the contribution of labor and capital to the output. The major finding of the study is that the share of labor was 3/4 and that of capital was 1/4 in the national income. After the Second World War, it is used in the analytical studies of individual industries and firms. The Cobb-Douglas production function assumes that there are two inputs, labor and capital. It represents constant returns to scale and hence is linearly homogeneous. The Cobb-Douglas production function can be expressed in the following mathematical formula. P is equal to AL K. Q is equal to AL alpha K beta. Q is output, A positive constant, K capital employed, L labor employed. Alpha and beta positive functions shows the elasticity coefficient of output for input. The homogeneity of the Cobb-Douglas production function can be checked by adding the values of alpha and beta. In the sum of these parameters equal to 1, then it shows that the production function is homogeneous and there are constant returns to scale. Thank you.